Now let's discuss another pressing issue faced by coastlines, namely coastal erosion, the trends, causes, and solutions regarding the issue. Let us first keep in mind that coastlines are shaped by sediment supply. Accretion occurs when the supply of sediment is higher than the loss of sediments, which leads to an advancing shoreline or shoreline advance. A stable beach occurs when the supply and loss of sediments are of the same rates and the shoreline maintains its shape and position. Finally, when the rate of supply of sediments in a coast is less than the rate of loss, a phenomenon called coastal erosion occurs. What is coastal erosion? Coastal erosion refers to the breaking down and removal of material along a coastline due to the movement of wind and water. It is manifested as shoreline retreat or landward movement, which leads to the narrowing and/or disappearance of beaches. As you can see, the shoreline in the image taken in Florida was initially wider than it currently is due to coastal erosion, which was caused by Hurricane Irma in 2017. So what causes coastal erosion? Remember from the previous slides that when the rate of supply of sediments in a coast is less than the rate of loss, coastal erosion occurs. In other words, coastal erosion occurs when there is a deficit in the supply of sediments to the coast. This may be caused by two things. First, it may be caused by a decrease in sediment supply from the nearby watershed or the adjacent offshore areas. The lack of sediments from these reservoirs fail to compensate for the sediments removed by nearshore processes such as waves, tides, and currents. Second, the presence of stronger waves and currents and more frequent storms may enhance sediment removal along the coast. Thus, in order to understand the processes involved in coastal erosion, it is important to know the sources and transport pathways of sediments along the coast. Let us now take a look at coastal erosion in the Philippines and the factors that contribute to it. The image on the right is a visual report of a survey on accretion and erosion in the Philippine shoreline between 2001 and 2005, where the yellow stars symbolize areas of erosion. Of the 625 kilometers of shoreline surveyed, it was found that 50% are eroding. The following are some of the findings of the survey which highlight some immediate causes of erosion. Erosion is greatest along siliciclastic coasts such as La Union. Siliciclastic refers to non-carbonate sediments that are sourced from older rocks and are typically delivered to the coast via rivers. In the Verde Island Passage, erosion is localized in areas with ports, groins, and seawalls. Beaches popular to tourists such as Boracay experience erosion. Furthermore, since island beaches are typically narrow, erosion of even just a few meters is already becoming a cause for concern. Thus, in order to address these issues, we must identify the factors that contribute to coastal erosion. The following are the main causes of coastal erosion in the Philippines: shifts in river mouth position, beach mining, degradation of coastal habitats, hard coastal structures, sea level rise, and storms. Shifts in river mouth positions. The following image shows the evolution of a shoreline's position from 1944 to 1991. The red line shows the shape of the shoreline back in 1944, while the black one shows its shape as of 1991. As you can see, the left side of the image depicts a shoreline retreat due to erosion, and on the right, we can see a shoreline advance due to accretion. Remember that siliciclastic beaches obtain sediments from rivers. The imbalance in sediments is caused by the channel leading to the Agno-Labrador River being rerouted to the Agno-Lingayen River in the 1930s in order to alleviate inland flooding. Beach mining. Beach mining refers to the exploitation of the economic concentrations of the heavy minerals which occur in sand dunes, beaches, coastal plains, and deposits located inland from the shoreline. One example of which is magnetite sand mining. Magnetite sand is widely used in the manufacturing of concrete and steel products and is a heavily sought-after resource. Between the late 60s to mid-70s, 2 million cubic meters of black sand was extracted from the beaches of La Union, which is equivalent to roughly 30 meters of shoreline retreat with 1 meter deepening. The mining of magnetite sand also results in looser and lighter sand, making it more susceptible to erosion due to waves and tides. Degradation of coastal habitats. In contrast to siliciclastic beaches, the sediments in carbonate beaches are supplied by aquatic organisms that live in nearby habitats such as seagrass meadows and coral reefs, the destruction of which results in a lower supply of sediments. Pamilacan Island in Bohol, whose beaches are composed of carbonate sediments from coral fragments and shells, experiences coastal erosion most likely due to the poor condition of its nearby reef. Coastal habitats do not only serve as suppliers of carbonate sediments, rather they also serve as wave buffers. If we recall from our previous lessons, reefs serve as wave buffers that break strong ocean waves before they reach the coast. According to the UNESCO State of the World's Oceans report, at least 70 to 90% of the energy from wind-generated waves is absorbed by these habitats, depending on how healthy these ecosystems are and their physical and ecological characteristics. Wave buffering is an important process provided by reefs that prevents strong waves from further contributing to coastal erosion. Let us now talk about hard coastal structures and how they can cause coastal erosion. Let us first introduce the concept of coastal compartments and longshore currents. Coastal compartments refer to a coastal segment where sediment sources, sinks, and transports are confined. They consist of a linear beach bounded by rivers and cliffs called headland, an embayed beach, or a pocket beach. Within a coastal compartment, sediments are carried from sources such as rivers to the sinks or the beaches by a longshore current or currents whose net direction is parallel to the coast. It is important that the pathway of longshore currents remain uninterrupted in order to maintain a stable beach. Here we can see coastal erosion caused by a hard coastal structure in Bawang La Union. The image on the left is a wider view of a linear beach in Bawang La Union, bounded by Bawang River to the north and Aringay River to the south. Bawang River serves as the source of sediments which are transported to the Bawang coastline via a southward longshore current. The image on the right shows how a pier owned by the BPPC or Bawang Power Plant Corporation blocks the pathway of longshore currents. This caused the shoreline retreat along the Bawang coastline. In order to prevent this, alternatives to hard coastal structures must be explored. An alternative to such design would be a pier supported by stilts or piles which prevent the interruption of longshore currents. Groins are another hard coastal structure that causes coastal erosion. Groins are designed to reduce strong waves brought by longshore currents and to trap sediments. There is accretion in the updrift side of the groin, leaving the downdrift side susceptible to erosion. Now let's discuss how sea level rise can cause coastal erosion. Rising sea levels allow for higher tides, which make coastlines more susceptible to erosion caused by nearshore activities such as waves and currents. Furthermore, a higher sea level creates more space for sediments to occupy underwater, reducing the amount of sediments present on the shore. Let us now discuss the last cause of coastal erosion: storms. The high energy waves produced during storms and typhoons can cause rapid coastal erosion from which beaches can recover given that there is an adequate supply of sediments. However, frequent storms may prevent beach recovery. The predicted increase in typhoon frequency due to climate change may affect the recovery of beaches ravaged by storms. Now that we know all of these factors that contribute to coastal erosion, we must now ask the question: how can we solve coastal erosion? What steps can we take in order to address this issue? The first step is to establish that there is an occurrence of coastal erosion. This can be done by superimposing and comparing historical coastal images derived from maps and satellites in order to visualize whether coastal erosion is present in a coast or not. Second, we must identify the possible causes of erosion. Identifying the immediate cause of coastal erosion is necessary in order to design a proper mitigation strategy. Finally, we identify the possible measures we can take in order to address coastal erosion. This may include Hazard avoidance, which consists of implementation of easement policies designed to promote responsible development by recognizing and avoiding future coastal hazards before they are even an issue. Another measure we could take would be relocation, which consists of relocating communities that live in chronically eroding and erosion-prone areas. Lastly, we must protect the coasts. This can be done using soft measures such as beach nourishment and the protection and rehabilitation of coral reefs. Hard structures may also be built in order to protect the coasts, however, they must always be our last option. That concludes this portion of the report.